We want to look at two more examples of finding intercepts for rational functions. We'll start off the same way, where we state that our denominator can't equal 0, and that would happen if x is equal to 0 in this case. So x cannot equal 0 is our one restricted value. We'll take the denominator, set equal to 0, and solving will give us x equals 0. But as we just stated, that's a restricted value, so the only potential x-intercept that we came up with is outside the domain of this function. So we would answer d(any) or does not exist. Then to find any y-intercepts for this function, based off what we saw in example 5, we might already recognize that this is going to be another case where the answer does not exist. Keep in mind that a y-intercept is always of the form 0, y, so that x-intercept has to be 0. If x is a restricted value, meaning it's outside the domain, then there's no way to have a y-intercept. In example 7, we'll again look at identifying any restricted values in our function. Since our denominator can't equal 0, that means that x cannot equal 1/2. We'll take our numerator, set equal to 0, and just look out for the possibility that we end up with x equals 1/2 as a result. Setting those two factors in the numerator each equal to 0 gives us two solutions, x equals 3/5 and x equals 1/2. Like we just stated, x equals 1/2 is a restricted value, it's outside the domain. So even though we come up with two values, we only have a single x-intercept of 3/5, 0. To find the y-intercept, we'll evaluate h of 0, which will end up giving us 0 plus 3 times 0 plus 2 all over 0 plus 2 squared, or 6 over 4, which will reduce to not 2, but 3/2. This gives us a y-intercept of 0, 3/2. Since x equals 0 is part of the domain of the function, we retain that as a valid y-intercept.